Describing chemical reactions. Word equations. Word equations is the way that we describe chemical reactions using words. Examples are magnesium metal burns in oxygen gas with a bright light to make a white powder called magnesium oxide. This transferred to an equation will be magnesium S, indicates that it's a solid, plus oxygen, that is a gas, transforms into magnesium oxide, that is a solid plus heat. Number 2, a solution of sodium iodide is added to a solution of potassium nitrate to make a potassium iodide precipitate and a sodium nitrate solution. This transfer to an equation will be sodium iodide, aqueous, plus potassium nitrate, aqueous, yields to potassium iodide solid plus sodium nitrate, aqueous. Another example is gaseous hydrogen and gaseous oxygen react explosively to form water vapor. Hydrogen gas plus oxygen as gas yields to water plus heat. Word equations. Activity. Perform the reaction below. Describe the reactants. Describe the products. Write a word equation for the reaction and classify the reaction as either a physical change or a chemical change. The reaction. Light a butane lighter. Watch the butane combine with air to form carbon dioxide gas and water vapor. According to this, the reactants will be butane gas and oxygen gas from air. The products, carbon dioxide gas and water vapor. The word equation, it will be butane as gas, we can use a G for indicating that it's a gas, plus oxygen as gas, produces or yields, as we call it in chemistry, carbon dioxide as gas, and water vapor or steam. Also is produce heat. According to this, you can see that this chemical reaction is actually a chemical change. Now, chemical equation. Chemical equation is a quick, shortened notation to convey as much information as possible about what happens in the chemical reaction. In here, the example is we have iron, and we combine it with steam, and that produces ferric oxide and hydrogen. As we can see in the reaction is called reversible. A reversible reaction is a reaction that can work from reactants to products and then to vice versa, go to products to reactants. Also in this reaction we are using S for indicating the state of a solid in iron, L for liquid, G for gas as it is in hydrogen. And when we have a substance dissolved in water, we are going to call it aqueous solution and we are going to be using AQ. In the arrow that we indicate from reactants to products, if we find a triangle on top of it or the word heat, that means that heat is supplied to the reaction to happen. Word equations. Practice activities. In order to test yourself in word equations to chemical equations, go ahead and try yourself in these two links online. To work with this, stop the video now and practice. Law of conservation of mass. The atoms in the products are the same as the atoms in the reactants, and they are just rearranged. This comes from Dalton's theory. An example for this, suppose that you are making a banana milkshake, in which you're using milk, bananas, spoons of sugar, vanilla drops, and finally you got your vanilla milkshake. The skeleton equation is a skeleton equation where we are going to be using letters for indicating the different components that we have, and numbers for indicating the quantities that we have of them. For milk, we're using M, bananas B, sugar S, and vanilla V. As we can see, the amount of them is stated in the vanilla milkshake. In the left, we have the reactants. In the right, we have the products. And finally, we need to use coefficients, which are numbers that appear in front of those letters that we are using, or subscripts that are the small numbers that we have at the bottom of these letters, in order to make the equation to be balanced according to Dalton's theory. Another thing that is important to understand is a catalyst. A catalyst is a substance that speeds up the reaction, but it isn't used up in the reaction. For example, in here we have carbon monoxide, and we are adding oxygen in the presence of palladium, which is the catalyst, to produce carbon dioxide. Palladium is not used at all in the reaction, but palladium helps to either turn one of the compounds or molecules into a polar molecule and to make it easier for the reaction to happen, or by having or producing a subproduct in the middle of the process that we cannot see at the end of the process when it's totally done.